Thanks everyone for joining this session. So let's start with why do we need a containerization, or why do we need a containerized application? So let's just go through an example that if you're testing an Python application of a lower version, say 2.7, and it's gonna run on a Python version 3 in your production, there's gonna be compatibility issues, and on top of that, there might be scenarios where your network topology might be different, or your security policies and storage might be different. So to address all these, we might we are introducing containers. So containers, simply put, consist of an entire runtime environment, an application plus all its dependencies, libraries, and other binaries with the configuration files needed to run it, all bundled into one package. So by containerizing the application platform and its dependencies, differences in the OS distribution underlying infrastructures are abstracted away. So containerization, basically, the main benefit is that we require far fewer resources than our traditional approach. It enables our developers to fully own and set up the configuration of their runtime app environment. So it basically a solution for simplification of a DevOps deployment toolchain. So that being said, let's just compare it with the virtual machines that we had versus the containers. So with virtualization technology, the package that can be passed around is a virtual machine, and it includes an entire operating system as well as the application. So for instance, a physical server running 3 virtual machines would have to have a hypervisor and 3 separate operating systems running on top of it, as you can see in the picture. So by contrast, a server running 3 containerized applications with Docker runs in a single operating system, and each container shares the operating system kernel with the other containers. So the shared parts of the operating systems are read-only, while each container has its own mount for writing. That means the containers are much more lightweight and use far fewer resources than VMs. So they are cost efficient, as a single server can host far more containers than a virtual machine and achieve the same job at hand. One more benefit that we can say for virtual machine is that it takes about several minutes to boot up their operating system and begin running the applications that they host, while containerized application can be started almost instantly. So that means that containers can be instantiated in just-in-time fashion when they are needed and can disappear away when they are no longer needed. So containerization allows for great modularity. So as said before, containers are lightweight. We can see that every app, every copy of an app, and every slight modification of an app requires a new virtual server. While in contrast to containers need no OS to take up space resources or require restart, and hence they are lightweight. So let's just move on and see what Docker really is. So Docker is a container system for code, and it encapsulates all our resources, say static website or any user database, web front end, and everything, and compiles it into one image, and we can put this image into our instances that we deploy in our cloud environment. The main thing about Docker is that the developer and a DevOps operator can work together independently without hampering the progress of one another. So let's just quickly look at some features of Docker container. So Docker container are content agnostic, that every dependency and payload are encapsulated within a single component. So there's no problem moving from one component to another. They are hardware agnostic as well. They don't take much of the system or memory resources, any CPU footprint, and it works much faster than a VM. For content isolation and interaction, when you package one component into a Docker image, you can implement various applications enclosed in a Docker container, and different containers can be hosted on a single machine, and this will work independently. Automation, just we can use a CI/CD pipeline, and we don't have to worry about any underlying code, as Docker will cover it all and help us automate. Since Docker has a very small footprint compared to VMs, they are highly efficient, and we can run them across multiple clusters without compromising on the performance. And one more cool feature about Docker container is the separation of duties, where the developer can write code and the DevOps person can implement across environment and need not have any platform worries as and when there are any changes for the infrastructure. So let's so we have seen the features of the Docker container. Let's see the use cases for them. I have just listed down 8, but they are not limited to these 8 use cases. So let's just see them one by one. So Docker can be used for simplifying configuration. It provides ability to run any platform with its own config on top of any infrastructure without the overhead of a VM. There's code pipeline management, which provides Docker provides a consistent environment for the application from dev to production, ease of code deployment, and development pipeline. So there's another use case in which we can use for app isolation. So there are multiple cases where you need to have isolation among application and server consolidation for decreasing the cost, or a plan to separate monolithic application into decoupled pieces. So for example, you might need to run, let's say, 2 REST API servers, and both of them would require Apache, but each of them uses a slightly different version, and they have some other dependencies. So we can, so app isolation comes into picture, and it will just run on their environment without hampering your application. So for server consolidation, the Docker also allows consolidating multiple servers to save cost without the memory footprint of multiple OSs and the ability to share unused memory across the instances. There's rapid development using Docker, and we can create any containers in up to, say, just milliseconds, and this is achieved by containers, and we are not booting up an OS, we are just running the application process. With regards to multi-tenancy, another use of Docker is that we use it in multi-tenant applications, thereby we avoid major application rewrites. Using Docker, it's really easy and inexpensive to create isolated environments for running multiple instances of app tiers for each tenant. And Docker spins it up very fast. And it has easy to use API, which we can use to spin up containers programmatically as well. So these are some of the use cases that Docker can be used. And now that we have seen what Docker containers are, let's see how we can deploy it in ECS. So what is ECS? So ECS is Amazon EC2 container service, and which is a highly scalable, fast container management service. We can easily run, stop, and manage our Docker containers on a cluster of Amazon EC2 instances. So ECS takes care of everything, like deploying those containers across clusters, if we have to roll out any new versions, and it seamlessly integrates with the AWS infrastructure. So in case we want a highly available ECS architecture without minimum downtime, this is how we can create it. We can create an ECS cluster with instances and auto scaling configured and put it behind an elastic load balancer to make it highly available across your environment. So now that we have seen how to create containers and how to deploy them in ECS, let's just quickly see what microservices are all about. So in contrast, for a monolithic application, microservices are primarily created to just concentrate on just one thing and do it well. So they are basically a service oriented architecture composed of loosely coupled elements and have bounded context. So basically, microservices will be having its own public API through which they talk to each other. And due to this, we have high level of abstraction as it hides your data. It even evolves your API in a backward compatible way and also documents. So apart from that, we can also use microservices for any polyglot persistence. Like we can have any number of any type of DB for your environment, and it can also embrace polyglot architecture. So this was just about microservices, and let's just jump in to an overview of Jenkins. So Jenkins, now that we have our containers and ECS has deployed that container, and we can just see that how Jenkins can help in our CI/CD pipeline. So Jenkins is a continuous integration and continuous delivery service. So the basic idea of continuous integration is to merge code from developers and continuously just test and deploy them. So continuous delivery just ensures that all of the codes from the individual developers are merged and always in production ready state. So it's basically a workflow engine to manage its CI/CD pipeline from source to delivery. So it's an end-to-end code pipeline solution. So these are a bit features of Jenkins. It has over 1,000 plugins. It has integration over 100 DevOps tool. It is an orchestration of DevOps toolchain and manages end-to-end CD pipeline management. Also, this is just master slave configuration in Jenkins, where we can see that each of our environment is segregated into different nodes and is managed by a singular master node. And we'll see more about Jenkins later in the demo, where Joseph will show on how we can use a containerized application. So having seen all that, let's just see some challenges that are usually faced in deploying the containerized services. So as any new technology would emerge, one of the biggest challenges is to have the right and the skilled resources. Since this is a fast evolving technology, we need to adapt to the change. Organizational inertia, our organization should be well equipped to handle those changes. And then comes the choice of technology, which is a main one, because whenever we are developing or designing our product, our choice of technologies should be proper, and we need to have a right implementation strategy to implement our design. In addition to that, we need to have some sort of mechanism to continuously monitor our container so that we know, like, whenever something goes wrong, we get alerted. And container security is also one of a challenge you can see for a modern containerized application. So now that we have seen these challenges, let's just look into some best practices that are used for running the microservices or ECS on AWS platform. So microservice, a few best practices would be that we have to extensively rely on the public APIs as they do the talking with each other or with the other services. We need to use the right tools for the job. We have to ensure that we secure our services and always put monitoring in place. We need to on top of that, we also need to account for any organizational changes, and always automation helps over everything, right? So we can put all of this into a CI/CD pipeline and monitor. So apart from that, let's just look at some ECS best practices. So in ECS, we have to configure our own instances, load balancing, logging, monitoring, and create task definition. So we need to make sure that we version control all of this. And another great practice would be that we use the application load balancer over an elastic load balancer, as it's more efficient and well equipped to go along with microservices. We can also have even application load balancing also has enhanced CloudBot and access logs. So we can also, one more thing that we have to take care is we have to plan in detail infrastructure wise and then automate. So then we can have the optimum resource usage, like we have to utilize the task placement policies, sensible usage limits, set our cluster and service scaling policies to ensure maximum resource usability. And always we have to look out for alerts. Like we have to apply maximum alerts because as our services and cluster scales, we need to add checks for parsing the logs and alerts to minimize any issue or noise. We need to take advantage of built-in AWS tools. So CloudWatch is a pretty good AWS service, and even the AWS Logs driver. So even though like even for our clusters, they should be placed in behind an auto scaling group to preserve any instance capacity, and we'll need to apply AMI updates gracefully, among other things. So keeping all this in mind, if we ensure these best practices, we'll have a good containerized application for our product. So moving over, let's just jump into the demo that Joseph is gonna present, and I'll just hand over the control to Joseph now, because he will be showing us an overview of the code pipeline of the demo and will be presenting the demo itself. So Joseph?
Yes, thank you very much. If you can go to the next slide here. So what we're looking at today is kind of a couple of different components of the discussion. The first part is we're going to be going through some AWS solutions, managed services that can help with continuous integration, continuous delivery and deployment. And then we're going to go through a demo that kind of showcases a lot of what we've talked about here in the discussion today. Kind of going back through some of those ECS best practices that were just covered. We're going to go through different ways that you can version your task definitions, different ways that you can revert to previous commits, how you can visualize these things to even figure out what commit I wanted to associate with a particular container, how to deploy this with the utilization of a load balancer, to ensure optimum resource utilization and to ensure optimum cost efficiency with our types of deployments. and to ensure that, we have great visibility into this process that we're looking at right now, which is that of the continuous delivery and continuous deployment. So kind of starting off, we're looking at the source code and how it is that we're storing this information. In the demos today, we're going to be kind of focusing on code commit, but our source method is really independent of the demo. It is whatever we kind of want to use. Built into Jenkins, there's a lot of different plugins that really enable you to get creative with some of your source systems. Even if we're looking at something like AWS Code Pipeline as your orchestration engine, we have opportunities with GitHub, we have opportunities with Code Commit, with S3. But when we look at this kind of deployment path here, we see the building of trust in our system, the ability to, automate not just that integration, but that delivery to these systems, whether it's to a staging environment, to a blue-green deployment directly to a production environment. There's a lot of testing that needs to take place in order to really trust the system to go from build straight to production, or with even minimal QA, QC testing. And that can certainly be a challenge because there's a lot of different components that we really want to focus on when we do testing. A lot of times we see a lot of emphasis on things like unit testing, on user acceptance testing, and there's still a lot of components that don't tend to get covered as much maybe as they should. Things like performance testing and API direct testing. And those are things that we can kind of see during the demo today. Do next slide. Here we see, we're going to be looking at some kind of high-level services from AWS offerings. AWS CodeStar is a relatively new service, and it's something that I always encourage users just to kind of check out, just to get a feel for what the code products are kind of capable of doing straight out of the box. It gives you a fully baked kind of environment where you can use the web code editor, the web IDE, in order to build code, have it automatically push and get to production. We're going to be looking at code pipeline as well today and how this fits into the model. The demo today will be focused on using Jenkins primarily for the build and push to ECS. But we're going to be using code pipeline in coordination with Jenkins in order to help orchestrate this pipeline. And what you'll see is there's a lot of interoperability between Jenkins and code pipeline. So they really do complement each other as it relates to integrating with the AWS platform. Code deploy, not used in this presentation or this demo specifically, but general tool used to just push a lot of these updates out to getting them onto ECS instances and making the data available in an automated fashion. We're going to be using code commit for the version control, and then code build as a separate demo available. We have some demos on YouTube for that, but just being able to utilize a managed service to be able to build these processes. So if we go to the next slide, what we're looking at is first and foremost, AWS code commit as our version system. So this is where our build pipeline starts off. In our example, this code commit repository, which we'll see during the demo, it contains our source code for our application. In this case, we're going to be using a Golang application, which requires a build process for compilation, and that creates a binary application that will be run within a container that creates a web application. Next slide. The next component here is if we wanted to utilize code build for this process, that would be definitely acceptable. As we stated, we're going to be building a binary application. So in our example, we're going to be using Jenkins for that build. And kind of the idea here is that we want to build as efficiently, as cost effectively as possible. So in order to do that, while using Jenkins, just as we talked about previously in this presentation, we have this kind of this master slash worker node relationship between these build providers. What we're going to be using is AWS Spot instances and Spot Fleet for those worker nodes, since we really don't care, how long these workers live, as long as they accomplish the tasks that we give them. We can receive a significant discount by running Spot Fleet instances, which allows for some significant cost savings. Next slide. Now, when we talked about trust, we talked about being able to, push code to your repository, and really having that trust to where I feel confident that I have enough testing and third-party tooling in place that this can go maybe even straight to a blue-green type of deployment. We really have to look at what tests are available. What kind of integrations have we performed? There was a slide earlier that showed a lot of different Jenkins module plugin integrations. There's a lot of great AWS partners that also exist in the space that really facilitate a lot of this testing that's necessary. As we kind of talked about, we want to make sure that unit testing is done. In our example, we're going to be using an AWS partner solution called Ghost Inspector to test that unit testing is passing for our application. But we also want to make sure that, the APIs that the front end is calling are functioning properly. For that, we might use something like RunScope, which is an AWS partner. And we want to make sure that not only is the unit testing passing, not only is the application functioning, but it also functions at scale and passes at scale. So we want to do load testing on our application. And we can use something like BlazeMeter, Micro Focus for those types of solutions. But it's really important that our application not just function, but functions at scale, tests out the components such as auto scaling to ensure that the application really performs acceptably across many different users and environments. The next slide. And then, kind of finally, what does it look like in order for us to get to production? In our example, once again, we're going to be using Jenkins to do this push to production, which we'll be deploying to ECS. Next slide. And now, what does this look like altogether? When we look at the general umbrella of each of these offerings, we see a full integration with the AWS Code Pipeline service. And this is the integration that we're going to be using for Jenkins. So Jenkins is really going to be doing the vast majority of the heavy lifting for us. It's going to be doing the compilation. It's going to be doing the task updates for ECS. It's going to be doing all the updates. But we're using Code Pipeline as just an element of the orchestration to showcase that everything works together in a happy model. And then next slide, this just shows kind of the overview of how, if you want to give it a shot, how all this is kind of brought together under the CodeStar umbrella to give you a fully functioning demo environment that's just kind of available out of the box. So if we go to the next slide, we've been kind of going through talking about what this demo is going to comprise. And so today, I actually work with the what's called the AWS Game Day program. And so for all of our examples, our hackathons, all of our events, we use a fictional company called Unicorn Rentals. So for today's example, we're going to be updating and deploying the Unicorn Rentals reservation lookup system. So in this demo, we have our application. It's running on ECS. It's behind a load balancer, and it's set to auto scale to meet demand. So we're going to perform an update on this. This is a Golang application, as we discussed. So you can't just push the code to production. You have to go through build processes. And, you know, the way you test that code is really up to you. But, you know, you should do things like, you know, language linting to make sure that, you know, you're following best practices, and that your code gets a little bit of inspection before going live, and it's not just passing a build. But we're going to showcase using code commit for the push. We're going to utilize Jenkins, a spot fleet build worker that is attached to the master to do the build of the binary application. Jenkins is then going to use the built-in the plugin for ECR, ECS, Spot Fleet, as well as the Golang plugins to build this image, update the necessary task definitions, and publish that new definition over to the AWS ECR service, which is our container repository that we can use to store AWS ECS images. So we'll showcase how versioning is done there, and show real time how you can see versions change after you do a check-in to GitHub. And then finally, we're going to tell the AWS ECS service that a new version is available of the task definition, and that it's time to update the service. So we can start playing the demo. And, you know, kind of starting off, we have our application. We have our Unicorn Rentals reservation lookup system, which we are going to be updating and kind of showing, you know, how the application backend can be updated. We're going to be updating some logs so you can see how this shows up when it comes to AWS CloudWatch. When it comes to ECS, our centralized logging solution is AWS CloudWatch. So our CloudWatch logs from all of these containers go to CloudWatch, which gives us a centralized solution in order to be able to monitor the application. So we can just start playing. Interestingly, we, you know, for this demo, you know, there's a lot of fun examples here. We actually make this available online. We have a video of this as well, with some additional demos that we can send out as a follow-up to the group. Different examples that, for instance, here we're showcasing ECS. We also have serverless examples. We have EC2 examples. We have Beanstalk examples, just to kind of fill all the demo kind of requirements to showcase how the build and deployment pipeline can work across all of these different types of applications. I think, so, sorry, is the demo playing? I kind of have a frozen screen.
Yes, Joseph, it's the Jenkins part is up. Do you want me to go over it again?
No, that's all right. No, no, my internet connection must be slow. But what we're looking at here is we have Spot Fleet, which is running the Jenkins worker nodes. And the idea here is that we only need each of these fleet instances to run for the duration that they need to build and deploy this application. So we give a price requirement and just say, it doesn't matter what type of instance, as long as it meets these minimum requirements. So fill this request based on whatever is the cheapest price for that request. So we're really pursuing an operational efficiency and cost optimization that kind of goes with this deployment model. We're using the Jenkins interface to be able to manage our Golang environment. We're checking in our code to AWS code commit, and we're able to really manage how it is that we're deploying each of these different infrastructure states. So here in the example, we saw a check-in to code commit. We have our application right now. It's being shown in our build pipeline. We've seen that we've pushed a task definition update. And now here we see our list of task definitions. As that list is updated, we see that there's a new task definition. It is tagged with latest and given a build number. And we can also see in real time how the task definitions are updated. So now in our library, we have an updated task definition number, and all that's left to do at this point after our code push is to have the pipeline automatically go through and say, there's a new version out there and you should be updating. And the container definition that we're taking a look at now, we've got our definition for our logs. We're making some small changes here just so that we can kind of look up what happens in the back end. For this example, we're using Fargate with a standard Docker configuration file that helps to define how it is that we're building this specific application. And this just is your standard Docker where we're adding our server binary and a couple of configuration files that go along with that application. We've broken out each source file uniquely so you can see the entire contents of the package. And so now, during this process, the code pipeline has detected that there's a change in code commit. It's passed this information off to Jenkins. The Jenkins master has received this request by polling SVM. And so what we're looking at now is it's utilizing the built-in Golang plugin. It's utilizing AWS Spot Fleet plugins, and it's pushing out that information that needs to be built to the worker. We can see some of the details of the workers. In fact, on the main configuration page of Jenkins, you'll see that there's some previous dead workers attached as well. And so those are left over from previous Spot Fleet cycles. So there's some old instances that we see here, and we have some newer instances. So these instances are constantly being cycled out as prices are changed. For something that builds pretty quick, like this Golang application, it really doesn't matter for us, but we can set Spot Fleet qualifiers to say that we want to make sure that every time that we get a new Spot Fleet instance, we want it available for X amount of time so that, if you're running a really long build, it doesn't die in the middle. In this, so we're seeing our example here, setting up the Golang build environment. We've got a bunch of libraries that need to be downloaded and installed. This is to showcase, what those libraries are. We'll typically use something like godep, gomod to automate that instead of listing them all out one by one. In our execution shell, which defines how it is that we're creating our task definition, there's actually, this is taken from a previous blog post that I wrote, where you can find on Google. It's Solano CI with ECR and ECS. And so that's actually available in a number of repositories for download. So you can just copy and paste that kind of in and update some variables. So we've done our update, and if you can see it fast enough, our task definition version has changed from 12 to 13, and these are the tasks that are actually deployed. So we made that change where we updated that string to say instead of server starting, Unicorn server is starting. And so now that is reflecting not just in CloudWatch logs, but in the ECS interface. We can now perform our lookup. We see that all of the old instances have been cycled, all the old containers have been cycled out, all of the new containers have been cycled in, and all this was automated and done completely in the background. If that build had failed at all, if there was a typo in the code, everything would have failed, and we would have still had the older version. We have our Jenkins output fully available here, which gives us everything that has taken place with the service. It's pretty detailed, which seems a little bit verbose until you actually need to dig through and find the information. So you can find where it is saved locally. We have our build artifacts because of code pipeline saved to S3. And now that we have the new version out there and deployed, we can see that Ghost Inspector has said, this has passed the test. And so we've been able to deploy this successfully and get it into our quote unquote production environment. And thank you. That is the demo for today. If there's any questions, we can hit those in a little bit.